Hey, welcome everyone to the 6th episode of Micropython series. Well, I'll make sure that you all get comfortable in using Micropython on the ESP32 board for any of your project. And this new episode, I'm shooting in the new studio, and by watching this episode, you'll be able to make your own home automation system using Mqtt protocol, in which you will be able to control up to 4 AC appliances using the Adafruit IO dashboard, and everything will be written in Micropython. So while watching this episode, you'll be learning about how to use the Mqtt package in Micropython. Then you also come to know what is this try-except block in Micropython and what's the purpose of it. After that, you'll also come to know what is sys.exit actually means and what's the use of it in Micropython. After that, we'll be making a very basic project of controlling an LED on our ESP32 board using Mqtt protocol, and by the end of the episode, we'll be making our own home automation project of controlling up to 4 AC appliances using Micropython using the Mqtt protocol. So this episode is going to be very interesting and very useful. So let's start this episode after a short ad. This video is sponsored by LTM, which is a PCB designer based software company. Now let me tell you one very interesting, very unique feature about this software which I bet you haven't seen in any other PCB designing software, and that feature is called as follow me mode. Now this is truly very useful feature which I can't explain it in simple words. Rather, let me show you the actual video of this particular feature. Have you seen that? The path automatically adapts the curve quite seamlessly. And now I can imagine making this kind of path in any other PCB designing software would be really a tedious task for sure. Now you can also try this and many other features of this PCB designing software by just clicking on the link mentioned in the description. Yes, by clicking on that link, you'll be getting a free trial version of LTM Designer software. So go ahead, try it out, and if you find it interesting, you can purchase this software later on. Now coming back to the video, so if you're watching this series for the very first time, I'll suggest you to watch out the previous episode of this Micropython series, whose link you will find in the description of this video, because each episode is kind of a continuation of the previous episode and we won't be discussing whatever that we have discussed in the previous episode. So do watch the whole series out, and that being said, let's start with the 6th episode. So this episode is all about Mqtt. So first of all, if you're not at all aware about this Mqtt protocol and how does it work and what is a client, what is a server, everything stuff like that, then I'll definitely recommend you to watch out a detailed explanatory video about the Mqtt protocol only, which is uploaded on my YouTube channel. So you can find the link in the description. Watch it out. I've given a very simple and very easy to understand example, and you'll be able to completely understand Mqtt after watching that video. So coming back to this episode, so first of all, I opened the Thorny on my system, and here inside the Thorny, I'll click on the new file. Now the code which I'll be using in this particular episode is already uploaded onto my GitHub repository. So you just need to go to github.com/techiesms. Inside the repository, you need to go to ESP32 Micropython series codes, and now into the episode 6. Here is the main.py, and this is the code that we'll be using for this episode. So I'll simply copy this particular code and I'll paste it inside my Thorny. Okay, now don't worry, I'll be explaining each and every line of the code in very detailed manner. Okay, so first of all, from machine we have imported pin because we want to turn on and off the built-in LED of this ESP32 board, pretty common. Imported network just because we need to make our ESP32 board get connected with the Wi-Fi router. Imported time because we'll be using the delay inside this code. And after that, here is the new package that we are using called as Mqtt. Now in case you want to check whether the Mqtt package is already available on your ESP32 Micropython version or not, you just need to type here as help into the bracket. You just need to type modules, close the bracket, and okay, so here are the built-in modules available on our Micropython version, and here as you can see the Mqtt/robust is available in the Micropython version. So we are good to go to use this package. And here in this from this whole package, we just imported Mqtt client, just we did here inside the machine import pin. Okay, so that's pretty common word now. Now you must be knowing if you have watched the previous episodes. After that, we have imported sy as the system package. Now why this is imported, I'll let you know while explaining the code. Okay, let's just move ahead. So first of all, we have declared a
a variable LED, which is nothing but the pin number 2, which is turned as an output pin, because the on pin number 2 we have the built-in LED on the ESP32 board, and that's why we have used this pin number 2, and we'll be controlling that LED using the Mqtt protocol. After that, you have to provide the SID name and password. Hey, come on, you just need to give access to this ESP32 board to internet so that it can communicate with the Mqtt broker, which is nothing but the Adafruit IO. Okay, so here I given the SID name and password, and after that here you have to provide the Mqtt client. So for using Mqtt, you need to define 4 things. Okay, first of all, the Mqtt client, which is nothing but a random client ID, just a random number you have to provide here. It can be name, it can be number. Okay, but make sure whenever you're using the ESP32 board or other Mqtt clients with the same Mqtt server, make sure each client has a unique ID. It can be anything, but it should be unique. So first of all, you have to provide Mqtt client ID. Second, you have to provide the URL, which is nothing but the server address. After that, you have to provide your username and you have to provide your key. Okay, so now how or where you can get these all details? Well, for that you have to go to what you can say io.adafruit.com, and this is an cloud Mqtt broker which is available for free. Okay, it also has a paid version, but free version is okay for our project related task. Okay, so io.adafruit.com is the website. Now here you need to make your account, and after making the account, it will be looking something like this. Okay, so I'll simply create a new dashboard here and name it as Micropython. Okay, you can give it name like any name you can give. After creating that dashboard, I'll go inside the Micropython dashboard, and here I'll be adding the button. Okay, for that you have to click on the setting icon and click on create a new block. I'll select a toggle button here, and here I'll select a new feed, and the feed name will be let's take example as a LED. Okay, let's click on the create button. I created the feed. Now I'll select the feed, I'll click on the next step, and now here we have to provide the title. In case we want, I'll provide as LED. Okay, and after that you have to provide the value that you want to send when the button is on. So I want to send as 1, and when the button is off, I'll to send as 0. Okay, and test value, let's just make it 0. Okay, click on create block. So it is that simple to create a toggle button on the adafruit.com website, which uses the Mqtt protocol. So we successfully created it. Now we have to provide a couple of credentials. The first credential is the client ID, which is nothing but the random number. Second is the server, the IO URL, which is nothing but io.adafruit.com. So this will be like kept it as it is. Now here username and AIO key will be different for different users. So in my case, the username is let's just click on the edit button. Click on edit layout. Now click on this setting icon. Okay, click on block info. Now here whatever you see is nothing but your username. In my case it is techiesms, so I will write here as a techiesms, and after that you have to provide the AIO key. Okay, so AIO key you will get by going into my key section, and this is nothing but the AIO key. I'll click on the copy button and I'll paste that key here. Okay, and after that one more thing which is remaining, which I missed out, which is nothing but the toggle feed ID. That means we need to provide the feed name whose data we want to monitor. Okay, so in our case we want to monitor the data of this button, so I'll click on the setting icon, click on block info, and this is nothing but the feed name, which is LED. So I need to provide the feed name or the topic name as LED. So these 4 or 5 credentials you need to enter for using any of the Mqtt broker. Okay, so we successfully did it. Let's move ahead with the code. So here we have defined a function called as connect Wi-Fi, which is nothing but a simple function that we have used in previous episodes as well. It will be connecting our what you can say ESP32 board to the nearby or the Wi-Fi router whose credentials we have provided. It will wait for 5 seconds, and if it is not at all connecting, it will print as not connected, and if it gets connected, it will print as connected. Now here I have added one more command, which is, or rather more line, which is sys.exit. Now what does this mean? So, and why it is important, let me tell you. So if this code is not connected, okay, what we want to do, we want to exit from our program. We don't want to move further, because if it is not connected, there is no use to move forward, because if there is no router, it won't be able to communicate with the Mqtt server as well. So what I did, if it is connected, no worry, just move ahead with the code, and if it is not connected, this command will stop running this Python script and it will come out of this Python script. Okay, so that's why I have added this particular command here. Okay, so that's the simple line, and that's the purpose of the sys.exit. So whenever you want your system to stop running the script maybe for any reason, maybe any of the condition is not satisfied, you can type the sys.exit function. Okay, straight after that we have used the connect Wi-Fi function, so we are calling this function to connect to the Wi-Fi router. And after that, here we have defined a client. Okay, so earlier we have defined all the credentials for Adafruit IO, that is the Mqtt server. Now here we are sending all that credentials to a function called as Mqtt client, using which it will be able to communicate with that particular server with our particular account. Okay, and how we are connecting is by using the client.connect function. Okay, so client.connect function will be communicating with our unique Adafruit IO Mqtt account. Okay, so now before client.connect, we do have one more thing, which is try. So what is this try? Well, try is written with the except block as well. So what is this try except block all about? Well, let me make you understand this by writing another script in Micropython. Okay, so what I'll do here, I will write as a is equal to 1 and b is equal to, let's say, 2. Okay, that's a simple example. And now what I'll do is I'll print a plus b. Okay, and it should be printed pretty fine, pretty normal. Let's just save it to the Micropython device with the name main.py. I'll click on OK. Okay, now let's click on the run button. As you can see, it is printed as 3, which was pretty much expected. Okay, so now let's just try to do something different. I'll type here as str. Okay, so this becomes string, and if I click on the save button and if I click on the run button, as you can see, it's throwing one error, says can't convert int object to string implicitly. Okay, so it is not performing, it's throwing the error to the line 4. Okay, so we can't add string with an integer, that's pretty common. Okay, but what if we have one more function running here, which is really important? Okay, I'll type as really important. Just try to visualize what's happening here. So what if we have, so we have printed here, and what if we have one more function which is really important to be executed no matter what happens? Okay, it's really very important. Okay, so if I now save this file and click on the run button, okay, as you can see, it is not able to convert this int into string, and this line is not at all printed, which was really important to be printed. So in this situations, the try except block will be very helpful. So how you can rectify this? So I'll write here as try, put a colon here, put an indentation here. So here what we are doing is we are letting the system know that, hey, try running this particular command, and in case if there is some exceptions or maybe there is some error in this line, what we are doing is we are providing exception as e. So we will be storing all the error that is coming while running this particular function. It will be stored inside the e variable, and what we are doing is we are just printing e. Okay, so e will be printed as an error, so whatever error we are facing, it will be printed here, and after that it will run the rest of the code. So now let's just save this script and let's try running this code or this script. Okay, as you can see, it printed can't convert int object into string. That was the error, but it still printed really important. Okay, so important spelling is wrong, but doesn't matter. So as you can see, by using try and except block, we can do the really important task even if there is error in some of the line of the code. Okay, so code won't stop running further. So that's the importance of try and except block, and that we have used here as well. I hope you got to know, I hope you got some basic idea about this block. So here what we are doing is we are letting the system know that, hey, try to connect to the client, and if in case there is some error coming, do try to print that error here, and after that just exit from this particular system, because if there is some error in the client, we won't be able to perform the further actions, and let's just kindly stop running the script. So here in this particular state, we are not running the other commands, but you can definitely run this kind of important commands by using this try except block. Okay, so in case it get connected, what I are doing is we have defined one function called as the callback function, which will be understanding after a moment. So after that, we have used a toggle feed variable, which is nothing but the actual address on which the data will be coming. Okay, so the format of that address in case of Adafruit IO is username / feeds / the name of the feed. Okay, in my case it is techiesms / feed / led. Okay, so on this address I'll be receiving the data, and that address is defined here, so you don't need to change anything here. Okay, after that we are setting the callback function as CB. That means if we are receiving any data, just call this callback function, and inside that callback function what we are doing is we are first of all printing the topic name and the message stored inside the topic name as it is by using the print function. After that we are fetching the message from that whole data, and in case the message is 0, like the received data is 0, we are turning off the LED. In case the received data is 1, we are turning on the LED. Okay, so that's the callback function. Simply turn on and off the LED. And after that we are also need to provide this particular line, which is client.subscribe toggle field. That means we are letting the system know that we need to subscribe to this particular topic only out of other topics available in the Mqtt server. Okay, that's pretty much it about the code. Now here inside the while true, that is the infinite loop, what we are doing is we are again running the try except block. That means, hey, just try checking the message. In case there is some error, just disconnect the client and exit from this Python. Okay, so by using this try except and system.exit, we are making our system, our code more stable. Okay, so it won't be resetting, it won't be rebooting the system, it will simply exit if in case there is some error. Okay, so that was all about this particular code. Okay, so now what I'll do is I'll simply save this inside my Micropython device as a main.py. Okay, okay, it's already open. So what I'll do, first of all, I'll stop running this. I'll delete this main.py from here. Okay, so it's got connected to the Wi-Fi router, and if I open the Adafruit IO and click on the on button, okay, the LED on the board started running, and here as you can see we also got the message as received data, which is 1 from the LED feed. And if I open the smartphone's camera to visualize it, so as you can see the inbuilt LED turned on, and I can turn it off easily by toggling this button. So off and on, off, on. Okay, so that's how we can easily send the data from the Mqtt server, which is received inside the ESP32 board, which is nothing but the Mqtt client. Okay, now let's just take this learning a step ahead and let's try to implement it in an actual project. So here I'll be using my previously made project, internet and manual home automation project, in which I have used 4 relays connected with the ESP32 board, and I also used the high link power supply, and everything was connected according to the circuit diagram. Now to make that project very compact and handy and easy to use as well, I made my own custom designed PCB for this project, whose order I gave directly to JLC PCB. I mean, you can order your own custom designed PCBs from JLC PCB by uploading the Gerber file of the PCB project, select the color masking if you want it, and just place your order. Now, selecting the fastest delivery option, you may get the PCBs delivered at your doorstep within a week. So do try ordering your own custom designed PCBs from JLC PCB to make your project looks neat and more compact. So after receiving the PCBs, we soldered all the components on it, and our final project, it looks like this. So yeah, that was all about the hardware part of the project. Now let's just quickly observe the Python script that will require to run this project. Okay, so here is the script that will be helpful to control 4 appliances connected to the ESP32 board. So what changes I made here is I have declared 4 different LED variables according to 4 different pins on the relay on which the relay is connected with. After that, here also I have defined 4 different toggle feed, okay, because we need to subscribe to 4 different topics here. After that, what you have to do is here inside the callback function, you first need to compare from which topic the data is coming, and after comparing, we are turning on and off the particular relay according to the data received on the particular topic. So that was all about the callback function. Now here we need to define 4 different toggle feed, as we'll be receiving the data from 4 different feeds, and also we need to subscribe to all that 4 feeds. Okay, so that was all about the changes that you have to do inside this Python script. Now talk about the changes in the Adafruit dashboard. Then here you have to click on the edit button, click on create new block, click on the toggle button, and here you have to add 4 different blocks with the name LED1, LED2, LED3 and LED4. After that, just create a button for each feed. So I'll select it quickly. I'll write it as LED1. On data value is 1, off data value is 0, test value is 0, and click on create block. Okay, so this is how I'll create the, okay, I'll remove this particular feed first of all. Okay, so similarly, I'll add 4 LEDs quickly. Okay, so yeah, that was all about the changes that you made inside the script and onto the Adafruit IO dashboard as well. And after that, what I did is I inserted the ESP32 board onto the PCB project. And now let's just visualize this project in action. So as you can see, I'm easily able to control the appliances connected to the ESP32 board using the mobile dashboard as well as the web dashboard. And it's pretty much in real time because Mqtt has a very less latency. So yeah, this is how you can create your own home automation project using Micropython and using Mqtt protocol, which is the most popular protocol in IoT. And also, now in the next episode, I'll let you know how to send the data from the client to the server side. So we'll be sending the data, like the census data from the ESP32 board to the Adafruit IO dashboard using Micropython. So make sure you subscribe to the channel if you don't want to miss out that episode and also upcoming more interesting videos on our channel. And well, that being said, I'm just ending this video here and now. Just wait for my next video. Explore, learn, share with me, techiesms.